In a remarkable leap from the cosmos to commercial energy solutions, a groundbreaking innovation has emerged from NASA's legacy of space exploration. The introduction of nickel-hydrogen battery technology, previously reserved for the most formidable space missions, has now been adapted for terrestrial use thanks to the efforts of California-based EnerVenue Inc. This technology, which has powered iconic space missions such as the Hubble Space Telescope and the International Space Station, is now set to transform the renewable energy landscape on Earth. EnerVenue's advancements have managed to significantly reduce the costs associated with nickel-hydrogen batteries, a feat achieved by eliminating the expensive platinum traditionally used in their construction. By removing the need for platinum, we have dramatically lowered the barrier to entry for these durable and efficient batteries, said Dr. Yi Cui, EnerVenue's chief technology advisor. This innovation not only makes the technology accessible to power plants and businesses but also paves the way for residential use, allowing homeowners to harness renewable energy sources more effectively. NASA first integrated nickel-hydrogen batteries into its systems in 1990, marking their debut with the Hubble Space Telescope, which has since become a symbol of astronomical exploration. For over 18 years, this technology provided reliable power to the International Space Station before being supplanted by lithium-ion batteries. Each nickel-hydrogen cell operates through a process that generates hydrogen, which is reabsorbed upon discharge within a highly pressurized vessel. This process contributes to the battery's longevity and reliability, qualities that have been honed through decades of NASA's rigorous testing in space. The transition of this space-grade technology to everyday applications is a testament to NASA's enduring role in technology transfer and innovation. As Dr. Cui pointed out, much of the groundwork for these batteries was laid by NASA's engineering efforts. Having laid the foundation and tested it in space, NASA paved the way for a durable power source that is now available for several applications on Earth, he noted. The implications of this development extend beyond just a new power source. They signify a substantial step towards integrating intermittent renewable energy sources into the grid, thus addressing the critical challenge of energy storage. With the increasing reliance on solar and wind energy, the ability to store energy efficiently and affordably is crucial for ensuring a steady power supply, which in turn supports the broader transition to a sustainable energy future. As EnerVenue continues to innovate within this space, the impact of their work may well shape the way we think about energy consumption and storage in the coming years. This new frontier not only exemplifies the potential of transferring technology from the space sector to everyday use but also underscores the importance of ongoing investment in scientific research and development. Looking ahead, the fusion of space technology with renewable energy solutions could play a pivotal role in addressing global energy challenges. As the world grapples with the urgent need for sustainable power sources, innovations like EnerVenue's nickel-hydrogen batteries could emerge as vital components of a cleaner, more resilient energy landscape. The future of energy may very well be tied to the stars. As the legacy of space exploration continues to illuminate paths on Earth. In a significant development for space research, the International Space Station ISS is buzzing with activity following the successful unloading of the SpaceX Dragon cargo spacecraft. This mission marks a new chapter in ongoing scientific investigations as the Expedition 73 crew embarks on a series of groundbreaking experiments designed to expand our understanding of life and microgravity. On April 22, 2025, the Dragon cargo spacecraft arrived at the ISS, delivering an impressive 6,700 pounds of scientific equipment and supplies. The vehicle docked with the Harmony module at 8:40 a.m. Eastern Daylight Time, allowing NASA astronaut Jonny Kim to open the hatch shortly thereafter. Unpacking the Dragon and activating these experiments is a critical step in our research agenda, said Kim, noting the importance of the newly arrived materials for ongoing studies. Among the first experiments activated was the Cell Gravisensing 3. Spearheaded by Commander Takuya Onishi of the Japan Aerospace Exploration Agency JAXA. This experiment aims to delve into the molecular mechanisms of cell behavior under microgravity conditions, potentially leading to innovative treatments for muscle and bone degeneration which parallel challenges faced by individuals on Earth. As Onishi set up the necessary hardware within the Kibo laboratory module, he emphasized the long-term implications of this research, stating, "Understanding cell responses in space could be pivotal in advancing medical science." In parallel, Kim and NASA flight engineer Nicole Ayres meticulously transferred research samples from Dragon's science freezers to the ISS's own facilities. The crew also initiated the biofilms experiment, which explores antimicrobial surfaces that could safeguard spacecraft from harmful bacteria. This study is particularly timely as space missions become longer and more complex, necessitating robust health safeguards. As the crew dives into their research, preparations for a spacewalk scheduled for May 1 are also underway. Ayres, alongside fellow astronaut and McLean, has begun configuring equipment for the upcoming excursion, which involves installing a modification kit on the station's truss structure. This upgrade is essential for accommodating a future solar array, underscoring the ISS's commitment to enhancing its operational capabilities. Meanwhile, Roscosmos cosmonauts Sergei Ryzhikov and Alexei Zabritsky engaged in unique experiments involving virtual reality technology to assess how microgravity affects their vision and balance. Such investigations are crucial for ensuring the well-being of astronauts during extended missions. Flight engineer Kirill Peskov also contributed by monitoring his heart rate and blood pressure with biomedical hardware over a 24-hour period, adding another layer of data to the ongoing health assessments of crew members. As the expedition's 73 crew embarks on this phase of research, the implications of their findings could extend far beyond the ISS. The intersection of space exploration and biomedical research holds the potential to unlock new treatments and technologies that benefit life on Earth. With the continuation of space missions and the increasing complexity of human activities in orbit, the results of these experiments are anticipated with great interest. Looking ahead, the ISS will remain a focal point of scientific inquiry, with future missions promising to build on the foundation laid by these current experiments. As NASA and its international partners push the boundaries of what is possible in space, the insights gained today will undoubtedly inform the next generation of space exploration and human health research. In an exciting initiative aimed at inspiring young minds, NASA astronaut Jonny Kim will engage with students from Santa Monica, California during a live connection from the International Space Station ISS on April 29, 2025. This event, which will be streamed on NASA's STEM YouTube channel at 12:10 p.m. Eastern Daylight Time, presents a unique opportunity for students to pose their questions related to science, technology, engineering, and mathematics STEM fields to Kim, who is currently serving as a flight engineer on Expedition 73. The event is a collaborative effort hosted by Santa Monica High School, where Kim is an alumnus, along with Roosevelt Elementary School and Lincoln Middle School. The schools have expressed their hope that this interaction will ignite curiosity and passion for learning among students. "We want to inspire the next generation to pursue their dreams," said a representative from Santa Monica High School, emphasizing the motivation behind this initiative. For over 24 years, the Islands has been a laboratory for scientific innovation where astronauts live and work continuously, conducting research that benefits humanity and laying the groundwork for future explorations beyond Earth. As part of this mission, astronauts communicate with NASA's Mission Control in Houston around the clock, utilizing the Space Communications and Navigation Scan Network to facilitate their operations. This educational outreach aligns with NASA's broader objectives, particularly the Artemis program, which aims to return humans to the Moon and eventually facilitate human exploration of Mars. The agency's commitment to fostering a new generation of explorers, termed the Artemis generation, underscores the importance of such engagements in maintaining the United States' leadership in space exploration. In related news, another prominent NASA astronaut, Don Pettit, recently returned to Earth after an extensive 7-month mission aboard the ISS. Pettit, who celebrated his 70th birthday upon returning, has accumulated a remarkable total of 590 days in space across 4 missions. His recent expedition involved conducting critical research on topics ranging from advanced water sanitation technologies to the behavior of fire in microgravity environments. Pettit will share insights from his mission during a live news conference on April 28, 2025 at NASA's Johnson Space Center in Houston, streamed on the agency's website. Participants will have the opportunity to ask questions via social media, further enhancing public engagement in space science. As NASA continues to lead in space exploration initiatives like Kim's upcoming interaction with students and Pettit's debriefing serve to inspire curiosity and innovation in the next generation. These efforts not only foster interest in STEM fields but also prepare young minds for the challenges and opportunities that lie ahead in humanity's quest to explore the cosmos. Looking forward, such initiatives will play a crucial role in shaping the future of space exploration and ensuring that the legacies of these astronauts influence aspiring scientists and engineers for years to come. As the world reflects on the 35th anniversary of the Hubble Space Telescope's launch, a veteran engineer from NASA's Glenn Research Center is celebrating a career that has been profoundly intertwined with the telescope's legacy. The Hubble, which has revolutionized our understanding of the universe, stands as a testament to decades of scientific exploration and discovery. Since its deployment in 1990, Hubble has provided breathtaking images and invaluable data, allowing astronomers to peer deeper into space and time than ever before. Amidst this celebration, the broader landscape of NASA's budget and its impact on scientific research raises critical concerns. Recent reports indicate significant proposed cuts to NASA's science budget, threatening to undermine the agency's foundational work in areas like astrobiology and planetary exploration. A stark example of this is articulated by Melissa Rice, a planetary science professor at Western Washington University. In a poignant commentary, she highlights that the proposed reductions, nearly 50% of the science budget, could jeopardize the Mars sample return mission, an endeavor poised to answer humanity's most profound questions about life beyond Earth. As someone directly involved with NASA's Mars missions, I can attest to the short-sightedness of these cuts, Rice stated. The Mars sample return is not just about collecting rock samples, it represents our best chance to determine if we are alone in the universe. With the Perseverance rover currently securing samples on Mars, the potential cancellation of this mission is alarming for scientists and students alike, as it would stifle opportunities for groundbreaking discoveries. In addition to the Mars missions, the proposed budget cuts would severely impact various scientific disciplines. Astrophysics, earth science, and heliophysics stand to face reductions of up to 68%, 53%, and 43% respectively. Such drastic measures could dismantle decades of research and innovation, leading to a significant loss of expertise and capabilities. These aren't just numbers, Rice emphasizes. Every percentage point represents real people, students, researchers, and innovators who rely on this funding to pursue their work. The implications of these budget cuts extend beyond the confines of academia. Local businesses that supply components for NASA missions like Goodwin's Composites in Mount Vernon also face dire consequences. The ripple effect could stifle innovation and economic growth in the aerospace sector, which has become a crucial pillar of the regional economy in Washington. For every tax dollar you pay, less than 0.2 of a penny goes to NASA's science programs, Rice argues, framing the proposed cuts as not just fiscally irresponsible but as a profound misallocation of national priorities. Meanwhile, in a demonstration of NASA's ongoing commitment to tackle pressing environmental issues, the agency's Iris-3 sensor recently provided crucial data on a wildfire near Castleberry, Alabama. This advanced imaging technology allowed firefighters to assess the situation in real time, showcasing the practical applications of NASA's research capabilities. By sending infrared data almost immediately, Iris-3 exemplifies how NASA's technological innovations can aid in disaster response and management. As the space agency navigates these challenging budgetary waters, the call for support for critical programs like astrobiology and environmental monitoring has never been more urgent. The scientific community is rallying to preserve NASA's legacy of exploration and discovery. emphasizing that the pursuit of knowledge about life beyond Earth and our own planet is not merely a scientific endeavor but a societal imperative. In closing, as we commemorate the remarkable achievements of the Hubble Space Telescope and reflect on its impact over the past 35 years, we must also advocate for the future of space exploration. The decisions made regarding NASA's budget will shape the trajectory of scientific inquiry for generations to come. It is a critical juncture where the question is not just about funding, it's about safeguarding our commitment to exploring the vast mysteries of the universe and ensuring that humanity's quest for knowledge continues unabated. NASA's Perseverance rover has made a captivating discovery on the Martian landscape, a peculiar rock named Skull Hill located on the edge of the Jezero crater. This unusual formation, with its dark hue and distinct angular surface, has sparked intrigue among scientists who suspect it may have originated from another location on the planet or even beyond. As Perseverance navigated down the west slope of Witch Hazel Hill, it arrived at a site designated Port Anson, where two bands of contrasting light and dark-toned rocks meet. This boundary is particularly significant for geological investigations, as it may reveal insights into the historical processes that have shaped Mars. The discovery of Skull Hill is further compounded by its classification as a float rock, a term used to describe rocks that have been transported from their original site, raising questions about its journey to its current position. Margaret Den, a PhD student at Purdue University, elaborated on the rock's uniqueness in a recent NASA blog post, noting its stark contrast with the surrounding lighter-toned outcrops. If you look closely, you might even spot spherules within the surrounding regolith, Den remarked, hinting at the potential significance of these small spherical structures found nearby. These spherules could provide critical clues regarding Mars' geological and perhaps even biological history. Theories about the origins of Skull Hill abound. One of the initial hypotheses was that it might be a meteorite akin to those previously identified by the Curiosity rover in Gale Crater. These meteorites are characterized by their dark color and high iron and nickel content. However, data collected from Perseverance suggests that Skull Hill does not share the same chemical signature as the meteorites found on Mars, which has led researchers to explore alternative explanations. Another possibility is that Skull Hill is an igneous rock formed from the cooling of magma or lava. Such rocks on both Earth and Mars often contain dark minerals including olivine and pyroxene, which contribute to their coloration. Den noted the significance of this hypothesis, stating, "On Earth and Mars, iron and magnesium are some of the main contributors to igneous rocks." Additionally, the theory that Skull Hill may have been ejected from an impact crater during a significant geological event cannot be dismissed. Impact cratering is known to create debris fields where rocks from deep within a planet's crust are scattered across the surface. This could imply that Skull Hill is a remnant of such an event transported to its current location from afar. As the Perseverance rover continues its mission, it is equipped with advanced instruments that will facilitate detailed analyses of Skull Hill, allowing scientists to uncover more about its composition and, by extension, its origin. This ongoing investigation promises to yield valuable information about Mars' geological history and its potential to have supported life. In conclusion, the discovery of Skull Hill not only enriches our understanding of the Martian terrain but also raises profound questions about the planet's past. As Perseverance delves deeper into its analysis, the answers gleaned from this enigmatic rock may illuminate the broader narrative of Mars and its geological evolution, setting the stage for future explorations that could unveil even more of the planet's secrets. In a groundbreaking collaboration that underscores the evolving landscape of international space research, China has announced its plan to lend moon rocks to several NASA-funded universities across the United States. This unprecedented move not only represents a significant gesture of cooperation between two nations with historically divergent space agendas, but it also highlights the growing importance of lunar studies in advancing our understanding of planetary science. The announcement, made on April 24, 2025, comes in the wake of increased global interest in lunar exploration, particularly as NASA gears up for its Artemis missions aimed at returning humans to the Moon. The moon rocks collected during China's Chang'e lunar missions are expected to provide invaluable data for researchers at U.S. institutions, allowing them to study the moon's geology, composition, and history in conjunction with ongoing American lunar sample analysis. This collaboration can enhance our understanding of the moon and foster a spirit of international scientific cooperation, remarked a spokesperson from the Chinese National Space Administration (CNSA). The lending of these lunar samples is emblematic of a broader trend as nations recognize the necessity of joining forces in the pursuit of knowledge about celestial bodies. It also marks a shift in China's approach to space diplomacy as it opens up its lunar research to foreign scientists, thereby increasing its standing in the global scientific community. "We are excited about the potential discoveries that can emerge from this partnership," stated Dr. Emily Chen, a leading geologist at one of the participating universities. "The insights gained from these samples could reshape our understanding of lunar formation processes." In parallel, NASA's Earth Observatory has been highlighting the similarities between the moon's surface and certain terrestrial landscapes, notably the craters of the Moon National Monument in Idaho. This area, characterized by its vast lava fields and unique geological features, has long served as a training ground for astronauts preparing for lunar missions. Recent satellite imagery captured by NASA's Landsat missions reveals the stark beauty of these volcanic landscapes, which bear a striking resemblance to the moon's surface. The craters of the moon, with its relatively young lava flows and diverse ecological systems, offers a unique analog for understanding lunar geology. Scientists have noted that studying the lava tubes and cinder cones in Idaho can provide insights into similar structures on the moon. As researchers continue to explore these terrestrial analogs, they are uncovering essential information about the processes that shaped both the Earth and its celestial neighbor. Amidst this burgeoning exploration of lunar and volcanic terrain, skywatchers are treated to an astronomical spectacle on April 25, 2025, when Venus and Saturn will join the crescent moon to create a rare smiley face formation in the early morning sky. This celestial event, highlighted by NASA, adds to the excitement surrounding space observation this month, which also includes the peak of the Lyrid meteor shower. Such events not only captivate the public's imagination but also serve to remind us of the dynamic and interconnected nature of our universe. As the collaboration between Chinese and American scientists unfolds, and as we look toward the skies for extraordinary celestial events, the future of lunar exploration appears more promising than ever. The exchange of knowledge and resources across borders could pave the way for groundbreaking discoveries that deepen our understanding of the moon and its role in the solar system. With both nations poised to advance their space agendas, the coming years may witness significant progress in lunar science and international cooperation in space exploration.